So I brought some friends. I'm here joined by my colleague Sona, who's a solution architect in Google Cloud, James, who's a data scientist at a creative agency Jellyfish, and Tim, who's CISO, Chief Information Security Officer, and Global Lead Analytics and Infrastructure at Colgate. Big data is big business. I put up two very generic data statistics to just prove out the size of the opportunity. But this is not new, right? The reason I put these two, though, is to show how this opportunity is twofold. If you want to increase return on investment, you can do two things. You can create more return, or you can lower the investment. So a lot of the things and the applications that you'll see can work in both ways. So either you can untap new opportunities, or you can do the things you're already doing in a more efficient way. A lot of the data that we talk about in the day-to-day is structured data. It's your advertising data. It's your CRM data. It's your structured databases that you can either access with a SQL query or a dashboard. But today we talk about unstructured data. And what is unstructured data? Unstructured data is the type of data that doesn't come with a predefined or an intuitive schema that is easily understood by machines. So machines can display it like photos, and you can browse through it. You can easily change them. But the machine will have a hard time telling you what's in the photo. The same with recorded audio, video, and an email, for instance. It's all digital, but it's hard for the machine to actually understand what is in the email. So this is where the big opportunity is. So if we know that 50% of organizations' structured data is actively used in decision making. This is a survey. This is probably on the high end even, because if you ask people, did they look at data before making a decision, a lot of people are going to say yes, but how many people actually did it, right? That number goes down to less than 1% if it's about unstructured data. For instance, you can think of all the recordings of your call center, right? Those are usually recorded for training and purposes. And what if you could actually tap into that information, right? Even in real time, can you pick up on things people are saying and trends? That's the type of data we will talk about today. This wouldn't be a Google talk if we wouldn't talk about AI and machine learning. And in this case, it really signifies that bridge between your unstructured data and your structured data. So you probably already have in place ways to deal with your structured data. But machine learning really is the bridge between those data sources. And Google Cloud then is really the opportunity for you to leverage and to use what Google has learned about data in the last decade or so, developing their own algorithms, and you can apply this to your own data set. So what is machine learning? Well, everything is illustrated by a cat and a dog. Deep neural networks is a form of machine learning, and it basically trains to recognize certain patterns in unstructured data. In this case, it's a photo, and it tries to figure out, it's a laundry basket, is that a cat or is that a dog? So the animation on the right signifies the different neural networks, different models that the ML application is trying to figure out what it is. And in the end, it says, OK, it's not a cat, it's a dog. This sounds simple, but what if you have to decide whether this is a Chihuahua or a muffin, right? This is really like, if your model can differentiate between these two, you're on the right way. Is it a Labradoodle or is it fried chicken? Sheepdog or mop, right? This really goes to show how delicate some of the differences are and how difficult it is if you want to build something that you can rely on in your decision making, right? Because sometimes 90% is not enough, right? You need to be sure. Luckily, Google Cloud has a suite of products that can address these concerns. And we're well aware of the fact that ML and AI, the opportunities present themselves at different stages and different locations in the company, right? You might have actual machine learning scientists, right, who write their own code, who build their own models. We have the TensorFlow network, the package. It's an SDK that really allows you to apply the cutting edge machine learning. But not everyone is equipped to do that, right? There's a whole bunch of data scientists that also might not want to do it, right? They want to, on the one hand, build something specific to your business, and on the other hand, really use the knowledge that Google already has about images, right? If you think of Google images, those are already all digitalized by Google. So there is ways to leverage that insights. One way is AutoML, and it's basically a hybrid. You use a little bit of Google, you use a bit of your own. And then in the left is the app developers, and those are the APIs. Those are really out-of-the-box, simple solutions where you make an API call, you send it a bit of text, you send it an image, and Google will tell you what's in it, a sentiment score. It goes pretty deep, and you will see into use cases what that actually looks like. But what does that all mean, and what do we care if we cannot make money out of it, right? So how do you go from unstructured data to business insights? So the last 5 minutes I've been talking about the role that machine learning plays, right? So you have your unstructured data, you run it through these APIs or through your models, and that brings you to structured data. So Google Cloud also has a great suite of products that allows you to work with that data, right? For instance, you can think of BigQuery, right? That could be a great destination for your structured data. And from there, you can apply your standard, more common analysis and really start driving those business insights. I mean, I work for Google, so you're probably like, well, what else is he going to say? That's why we brought 2 customers on stage who will talk about how they applied this type of logic in their business. And we'll start off with Jellyfish, and I'll hand it over to my colleague Sona, who will introduce the use case.
Perfect. Thank you so much, Sjef, for that introduction. So hi, everyone. My name is Sona Oakley. I am a senior solutions architect with Google Cloud, focusing on marketing analytics and machine learning. So today I'm going to partner with Jellyfish to talk a little bit about the Google technology that we use to help implement creative insights. And then the Jellyfish team will talk about the business value that unlocks for them. So firstly, when we think about unstructured data, every single company in the world has an advertising arm and a marketing arm. And we realize that we're sitting on a lot of images that we could then use to help generate these valuable business insights. So I'll start with a very basic definition of what is a creative, because I understand we may not all have a marketing background. So creatives are the visual materials that are used to generate leads and sell advertising or marketing. We are all familiar with these. We're here today at Next, and I know I've seen a bunch of Google Cloud creatives as I've been walking through, but I just wanted to level set that this is what we're talking about today. And more specifically, we're talking about creative analysis. So that's the comparison between 2 or more of these images to determine changes in performance. So when we're thinking about a marketing organization, we think about things like click-through rate, impressions, clicks as metrics of performance. And we want to understand how these 2 images compare and contrast in performance, as they're both here showcasing the same lip balm. So here we have the question: do lifestyle creatives perform better than product creatives? An example of a product creative is this one here in the middle, where we're showing just the product. And a lifestyle example is the one here on the right, where we actually have a model who's holding and interacting with the product. Now, as humans, this is really easy for us to look at, right? We can look and we can see that on the right there's a model, on the left there isn't. Therefore, we very easily classified this problem. But to Sjef's point earlier, how can we have a machine do this at scale? And that's what the power of Google machine learning can really bring to the picture here, is it'll help us to be able to identify these 2. The other question you might be asking yourselves is, why should we focus on creatives? There are so many other aspects of an advertising or marketing campaign, like targeting, like recency, like reach, for example, that we've been hyper-focused on as an industry. However, according to a recent Nielsen study, we saw that creatives still contribute to about 45% of overall sales. So making sure that we have high creative quality is imperative to our business. And it's almost a no-brainer when we're running these ads to make sure that the content of that creative is of high quality and resonating with our users and our customers. So that being said, if it's a no-brainer and we feel like everybody should be doing it and 50% of the business relies on it, why aren't we, right? So the main challenges that we face today are threefold. It's expensive, it's manual, and it's rigid. So it's expensive and manual because it takes a lot of human effort. If we think about our 2 creatives that we saw earlier, today we would need humans to actually go in and tag that the creative on the right was a lifestyle creative, it had a model in it, etc. And so that really limits us to only looking at a subset of our creatives. The other thing is that it's a very rigid process in that we have to think up of these use cases ahead of time. Because it's so expensive and so manual, we want to make sure that we're getting the most bang for our buck as we're going through this analysis process. So with Google and Jellyfish, we thought that there has to be a better way of doing this creative analysis piece. And we used Google Cloud technology to help do that. So the first thing is that we reduced costs using the Vision API, and I'll go through each of these pieces in detail, but I just wanted to generally introduce them. So we reduced costs by using the Vision API, which Sjef introduced, to do automatic creative analysis. Then we helped to automate that analysis by implementing a data pipeline. So that way we're not just looking at one creative, we can look at multiple creatives. And then lastly, we used App Engine to allow for flexible scaling here. So now instead of just looking at a set of 100, we can scale up to 1,000 or multi-thousands or even more using the same process. So that's how we solved for this. So the first thing that we did was evaluating the Cloud Vision APIs. While it might be fun to upload pictures of fried chicken and labradoodles, does this actually apply to advertising creatives, and does it have any business value for our marketing organizations? So that was the first thing that we wanted to try. And here, if we look at the sample creative, we had uploaded this to the Vision API, and we saw that it pulled out 3 labels that we thought were really important in doing this kind of analysis. The first is that it was able to identify very accurately faces and emotions. So not only can we now see that there's a model in those creatives, but we can actually see the emotions that they're expressing, whether it's joy, sorrow, anger, etc. The next thing was that we could do textual analysis. So in the bottom right where it says learn more, it was able to identify the text piece. And then lastly, we were able to identify the dominant colors. So this helps to ensure the quality of the creative by ensuring that our creatives are on brand and using the color scheme that's been recommended. So that first part was a success, and we were able to prove that it worked for one creative. But I don't know about you guys. For me, I don't really appreciate uploading one creative at a time and downloading them. So to that end, we went ahead and created a data pipeline that took our creatives out of Campaign Manager, which is a Google marketing platform product that houses all of an advertiser's campaign information and creative information in one place. So this was the data source for those creatives. We then took them and used App Engine for our pipeline orchestration. So this was where it kicked off the flow for the rest of the data pipeline. And what it did is that it published jobs to Cloud PubSub, which is an asynchronous messaging queue that then kicked off 2 separate work streams. The first is storing these raw assets in cloud storage so we could do analysis on them. And the second was running them through the Vision API to do image analysis and then storing all of those results back into BigQuery to run our results off of. So this is the architecture, and we'll actually go through a live demo of this. So let's see this in reality. If we're looking at this example here, one of the first customers that Jellyfish went to market with for this project was with Walden University. So here we have an example of 2 creatives, creative number 1 and creative number 2, and we want to understand which creatives show happy faces. And like if you guys have been to the keynotes, like many of our leaders have said, seeing is believing. So let's jump into a live demo of how this process works, and we'll switch over to the demo now. Could we please switch to the demo? Great. So the very first thing that we'll do is we'll actually try out the Vision API. So here, this is an online website. Anybody can go to cloud.google.com/vision and upload it with your own creatives. So I would recommend that you do that. Here I have downloaded the creatives already, so I'm just going to go ahead and drag and drop, verify that I am not a robot, in fact, and we'll see the analysis here. So in a matter of seconds, we were able to get back the API calls. Like I mentioned earlier, we wanted to look at faces. So here we've correctly identified that there's a face in the picture and that joy is very likely. So automatically, we're now identifying the creatives that have happy faces versus the ones that don't. The other thing that I had mentioned was the text analysis. So here we're able to pull out the text from each and every single creative and understand where they are. So let's go ahead and reset this and try it with our second creative. So let's make sure it works on both creatives before we move forward with the data pipeline piece. And again, we're able to see that the faces were identified and that this face is very neutral. It's not showing any likelihood of any emotion. The other thing that I wanted to highlight is that this, of course, is a UI view, so it's a very small view of what we'll actually be able to see when we call the API. Here, if we look at the JSON, we can see that these are all the information that's being recorded as the response. So we can actually see, for example, the bounding polygon and the vertices of the face itself. So it really enables you to do whatever kinds of creative insights it is that you want to as an organization. So now that we've proven that the Vision API piece works, let's go ahead and go into the actual data pipeline. We're going to go into Campaign Manager, like I mentioned earlier, which is the ad server tool that's a part of Google Marketing Platform. Here we're in Walden University's creatives, and we can actually see the number of creatives that have ran, and I can scroll down for eons on this. And if I just zoom into one of these creatives, we can see some of the issues, right? Is that the creative names here are really made for campaign performance. It helps us identify which campaign this creative was a part of, but it really doesn't give us any information about the content of the creative itself. So what we'll do is, right before I got on stage, I kicked off the data pipeline already. So we'll watch the data pipeline as it progresses. And what it's doing is it's taking this list of creatives and putting it through that process that I'd mentioned earlier. So I'll go ahead and go into my Google Cloud platform. And here we can see that I've kicked off the job in App Engine. We can also follow the logs in Stackdriver. So here, if I zoom into our logs, we can see that it's split out into two sections. The first is the visionary. So that's the Vision API actually doing the analysis on each individual creative. And then the second piece here is the GCS_uploader. So again, that is how we're uploading this information back into Google Cloud Storage. And then lastly, I wanted to show the data once it lands in BigQuery, because while I really enjoy getting, seeing all the details of how this pipeline works, I'm sure that for the business folks in the room, you really want to see what is the value of this data once it lands. So here I've gone ahead and pulled together a query, and before I go into it, I just wanted to highlight here on the left-hand side, we have the various tables that came out as a result of our data pipeline. So we have the face detection, we have additional image properties, we have label detection, logos, etc. And then lastly, we're able to join this with performance data. So now we're able to really implement creative analysis by seeing that performance data side by side with our images. So if I go ahead and run this query, here what we're going to see is the results. So these are the two creatives that we looked at earlier. And we see that in the first creative, the joy likelihood is 5, which is very high. And the second creative, the joy likelihood is 1. So here we have our very happy face and our not happy face. We were asked to redact the number of clicks and impressions due to privacy reasons. However, here you would be able to see that performance information, and we'd be able to compare and contrast the performance itself. Jellyfish will actually go into the details of how they were able to accomplish this test and more of the value, but I just wanted to show how if we lay that foundation of data, you're able to see all of this in one place. The other thing to note here on the right-hand side is that we've also been able to link out to the Google Cloud Storage URL, so if anybody wanted to go through and do a manual check of these creatives, it's really easy to do that. Before we leave our demo, the last thing I wanted to do was uncomment this one line in our query. So what if we had decided, instead of looking at happy faces, I want to understand if people who are wearing graduation caps in my creatives were able to perform better or worse. If I uncomment out this face annotation headwear likelihood and rerun the query, I'm able to edit my hypothesis in just a matter of seconds and see the results here. So here, if you remember in our creatives, the headwear, neither of them were wearing graduation caps, so we're able to see that here. But if you imagine that we're running this off of hundreds of creatives, not just one or two, then you can see exactly how impactful being able to pull this data pipeline together is. So do you mind please now going back to our presentation? Great, so thank you so much for listening to the explanation of the Google tools that help to power this. I will now hand it over to James from Jellyfish to go into the business value that this tool was able to provide.
My name's James. I'm a data scientist at Jellyfish. For those of you who don't know, Jellyfish, we are a global digital partner as well as a Google Marketing Platform and Google Cloud Platform certified partner. We offer a wide variety of services from creative development and analysis to media strategy data analysis, training, and much more. As part of the data team, we build solutions that help our clients understand their big data and then take these insights to inform their business processes. So how are we using this solution? Well, it augments our comprehensive data strategy by informing our data-driven creative development strategy. It helps us increase performance. As Sona mentioned, creatives account for a really significant amount of sales, and if we can just be a little bit better at creative, we can deliver significant performance lift. And to that end, it helps us quickly and efficiently discover what works and what doesn't with creative development. So the first thing we wanted to do was see if there was any meaningful information that we could pull out from the Vision API. And so we set up a series of tests using the adjusted viewable click-through rate as our performance metric, which is essentially clicks over total viewable impressions. We then split our creatives into 2 groups, having and not having a specific feature, and then finally used a 2-sample t-test to analyze significance. So our first hypothesis was that creatives with happy facial expressions have historically performed better than creatives with faces that did not have a happy expression. There were 184 creatives with happy faces and 16 without, and we found that creatives with happy faces performed 2 times better than creatives without happy facial expressions. For our second hypothesis, we were really interested in seeing what makes call to action buttons effective. In order to do that, we had to do a bit of feature engineering, which is one of the really cool things with the Google partnership, is that we're able to build on each other's work. So I used OpenCV, the computer vision library, to extract the location, color, contrast, size, etc. of the buttons. And then once we had the location of the button, we could cross-reference that with the Vision API data to find the text that appears inside the button. And then from there, we can find out what impacts performance positively or negatively in terms of the text. So our second hypothesis is that creatives with other text aside from follow your why in the CTA button have higher historical performance than creatives with follow your why in the CTA button. And there were 172 creatives with other text, 16 with follow your why, and we found that creatives with other text have historically performed 2 times better than creatives with follow your why. So we're really excited about this tool. It enables us to do much deeper creative analysis, and we've started working on a self-serve analytics dashboard, which will basically allow our clients to track the general performance of the different features of their creatives. And then we'll use this information to inform our hypothesis-driven analysis on the historical data. And then finally, we're going to start exploring building a machine learning model to predict performance based on the feature mix. Thank you so much, and I'm going to give it back to Sjef to talk about marketing insights from text.
Thanks, James. That was awesome. So I realized I forgot to introduce myself, but I got a second chance. So my name is Sjef. I'm a marketing technology specialist in Google Cloud. It means that I'm basically a customer engineer, but I work with our customers when they either bring in their own advertising data or they have their on-premise marketing solution, how to leverage Google Cloud and the advertising side of the house in our products. I have the privilege here to be with Tim. Tim joined us from Colgate-Palmolive, and we worked on a project that I will tell you about, where we did something similar as James showed you, and Sona, but then with text. And it's hard to underestimate the value of and the role of online reviews, right? So written text these days, whatever is out there, if it's on product review sites or it's on Reddit, if it's on blogs, consumers are offering up a lot of information about what they think of your products, what they think of your brands, what went well, what went wrong, and there's a lot of reviews out there. I looked up some numbers, and I believe, for instance, Yelp in 2018 had a number of 171 million reviews on that site. So there's no way you're going to read those, right? Maybe you have hired people to read those reviews and to pick up on problems or to think about new features that you can add to your product or your hotel or whatever business you're in. But that's a lot of work, right? And you might miss very important signals, especially if you're talking about thousands of SKUs that you would have to monitor. This is where natural language processing really has its benefit. And Google Cloud has 2 out-of-the-box ways to really leverage that technology. One is a pre-trained machine learning models. They come in the form of an API, and that's just an API call, like we saw with Sona and James with the Vision API. There was this version of it that does natural text. So you just send the body of text to the API, and it will return the fields with the different dimensions. You can also train your custom models. This is what I was talking about earlier, where you have this hybrid model where you leverage what Google knows and what you know. Especially if you're in a very specific sector, like if you're in law, or if it's a medical journal, or there might be jargon and certain subtleties that you as a company really are aware of, but Google didn't optimize their models for, right? So that's really where cloud AutoML comes in. So you train it to look for those specificities that you know that are out there. And that we really see solutions that start with an API graduating in AutoML. As soon as you start to see where that value is, that is really your next step to really leverage those subtleties. So the Cloud Natural Language API, this is what comes out. So you get a general score of the whole body of text. That comes with a magnitude. And I think we often talk about sentiment analysis, but I think magnitude or salience, as we see with entities, are very important features. Because something can be very negative, but if it's not central to your text, or if it's not very pronounced, then you might want to rank it lower, right? So it's a great way to start weighing your results. So even if you use the API and not an AutoML model, you're still able to really pick up on some subtleties, right? Because you start to see where the API might overgeneralize things. For entities, this is where you really leverage Google's knowledge graph. Right? Google has, for the last decades, really tried to figure out what are people talking about and how can we identify, for instance, in Google search, if you type something in, what are they actually referring to, right? So there might be 5 ways to talk about a car. You can now apply that knowledge graph to your text. So we'll say you talked about the Eiffel Tower, right? Or you talked about a cinema, or you talked about a conference. For all those entities, you get a sentiment score and a magnitude and salience. So you know how important that element was in the total body of the text. The same for sentences. It will break out the sentences, and it does language detection. So if you have an international market and you get reviews, for instance, in different languages, then you can use the API either to detect it, and it's now available in, I'm going to read it from the monitor, with English, Spanish, Japanese, Chinese, simplified and traditional, French, German, Italian, Korean, Portuguese, and Russian. And this list is growing. But you see that in a multilingual environment, this is really a tool that also works out of the box. So you won't have to translate. You won't have to hire people in different countries to do those analytics. So this is just the first review I ran into on Colgate toothpaste. It's this person's favorite toothpaste. It's good cavity-fighting toothpaste with added whitener. The whitening feature really works. Why wouldn't want a bigger smile? So you see, I'm not going to read it the whole, right? Because it's actually a lot of text. But that really goes to show that if you want to do this at scale, you need an automated solution. So similar to what Sona and James showed, we built a pipeline where we can analyze these reviews at scale. And it starts with a storage bucket. So as you might know, Google, BigQuery, and our data analytics really excel in situations where you have a combination of streaming and batching pipelines. So this is an example of how you add a batching pipeline to your architecture. So let's imagine this review comes in the storage bucket. There's a feature for Google Storage. It's called object notification. And what it does, as soon as a file arrives or when it's updated, it sends a pops-up notification to a topic of your choice. For people who are not aware or don't know what pops-up is a messaging service. It's basically a Slack group for applications. So it says, OK, I've found a new file. That triggers a cloud function. What that cloud function does is it picks up the review, and it makes the API call. So it just reads the file, and it sends the plain text to the API. The API runs it through all the Google magic, and it sends back the fields that we just walked through. The cloud function waits for the API to finish. It adds that data. It augments the file with that data and puts it back into cloud storage. You might wonder why you do the round trip in cloud storage. It's because you want to preserve like the initial state, so that if you decide to structure it differently in BigQuery or you want to build another pipeline, you have that data available. And with the storage options available, that it's very competitive. It's not expensive. But you don't have to do that. You can also directly pipe it into BigQuery if you want, if that suits your needs better. So from there, it arrives in BigQuery, and from there, it's structured data, right? And it becomes available for your analytics. So I'm going to switch to the demo right now. I'm going to show you what that looks like. So I copy-pasted, well, actually, Sona did, thank you. But she copy-pasted the review from that you just saw into the website. This is a similar online demo that you can just use on the Google Cloud website, and it shows you how the NLP API works. So if we press Analyze, it does really nice things with like pretty colors. This is the Entities tab, and it really shows the different entities that it has identified in this review. So it knows it's talking about cavities. It knows it's about toothpaste. It gives a type, so it knows it's consumer goods. It gives you sentiments for these different elements. It thinks whitener is a person, so that is an interesting observation. Colgate, so it understands that Google Total is an organization, and this really opens the door to also brand tracking, right? So you can start to see at scale how people are talking about your brand, not just about your product, right? And you can start to see which products might invite people to talk about your brand, right? So where is your brand exposure the biggest, right? And that could inform investment. That's not all. So we have sentiment. So we get a score for the whole entire document. So that's the 0.7 with a pretty hefty magnitude. And there you see what I promised per sentence. What is the sentiment and what is the magnitude? Then there is some very fancy, like if you know languages and you really want to dig in, Google also gives you syntax analysis. So it starts to designate certain words and parts of sentences, what they mean, and the role they play in the sentence. And this can be really informative if you want to start building models on top of this, right? If you want to see more linguistic analysis. Thank you. I'm going to switch back to the presentation. All right. So I mentioned him 3 times now, but he's finally coming. Tim, thank you for joining us. Yeah.
So I'm a little surprised. Whitening is a person. He runs around in our technology center and puts the secret whitening, and Google just discovered him. So it's trade secret out there for the world. No, happy to be here. Have a chance to really speak to what we're doing with Google, which is super exciting for me as I connect Colgate's data to decision makers to drive growth and value in our analytics program. Key to that is a flexible set of tools that empowers us to ride the wave of technology that's there. Takes an investment of skill, takes some really good partnerships to be able to do that. But once the flywheel starts moving, the applications proliferate really quickly. For the demo you just saw, once we built that capability, we found around 8 different use cases inside the company for that corpus of data. Much more important than the data set, though, is the flexible ability to go out and gather the data that we need. For example, if we started on reviews on an individual consumer retailer site, understood what products people might be asking for or sizes, pack mix that we might not be doing, we might not be presenting to the world, we might then pivot from that to looking at consumer affairs and our ability to respond with the limited people we have to what people are saying about our products, to translate them into different applications so that we can empower the teams that we already have. But data sets like that tend to be very useful in applications like e-commerce optimization. What's great about that is we don't end up with a balkanized set of tools, but we're empowered to take a set of data and a flexible acquisition capability, analysis capability, and then action capability, chain those together in a number of business cases. And that matters a lot. As a company, we have more than 3.5 billion customers that use our products around the world. By and large, the relationships with those customers are intermediated by the distributors, by the retailers that we sell those products through. So understanding what consumers want, what they think about our products, it's really important to be able to use the power tools that you're shown here, and it's important to put it in the context that Sjef showed, where we're able to move around blue hexagons and quickly rearrange and agilely focus our business where the value is going to be. The 3 points made here are first driven by the fact that the complex ecosystem that we're at in the world is discernible by the tools that you've seen here. That takes engineering and writing code. It takes an investment to partner and build that internally. That's a major effort of ours. The second part is we need to have partnerships to prime the pump to show what's possible in this type of context. Once you do that, you're past a barrier of entry and you can start to present to business users, whether it's in marketing, supply chain, product development, and start to proliferate the use cases. And then you enter into a virtuous cycle where demand for this type of capability goes up and you're able to increase your resource investment and capability in this area. And I think it's pretty clear from everyone that using GCP for us has been really helpful to start with a low barrier of entry and quickly move into doing complex things that we're able to expand across a diverse base of users. Love to talk to you afterwards about this, and thanks to Sjef for setting this up for us and showing us the way.
Awesome. So we will go ahead and do a really quick wrap up of what we've seen here today. So essentially you saw two different examples of how we can start to get insights from unstructured data at scale. The problems that both Colgate and Jellyfish articulated are not new problems. They're things that we've been dealing with and finding workarounds for. What's really new here is the innovations that Google Cloud has been able to bring from a tools and infrastructure perspective to really help solve these problems at scale. And that is, to Tim's point and to James's point, the power of the partnership between cloud and the customers that we work with.